Our second video in the Unit 1 series will be about Lesson 1.2, and this time we'll be looking at two variable equations. So the goal for this lesson is to, one, can we create, as we have right here, our targets, can we create equations in two variables that represent relationship between two variables? And then the second part will be, can we then graph these? In this video specifically, we'll be looking at, can we create these two variable relationships? Can we create these two quantities? So moving on to our problem, we will be returning back to our, like in section 1, our water park. This time specifically, we'll be looking at the renting of inner tubes. So if you want to at this point, you could pause and read all this information here. But the big things we have is the renting tube cost is a flat fee of $5 plus $2 per additional hour of rental. So that's going to be the information we're going to use throughout the next few problems in this series. So start with, we're going to make a table of values for how much it's going to cost if we rent the tube. Keeping in mind, we have it's a $5 flat rental fee plus $2 per hour that we have that. So if we were to have the inner tube for 1 hour, it's the $5, the flat fee, plus the $2 per hour for a total cost of $7. If we had the rental for 2 hours, again, the flat fee of $5, plus now we have 2 hours of $2 fees, or it's going to be $9. And hopefully you can start to see this, what's going on here. If we had it for 3 hours, it's $5, the 3 hours at a fixed rate of 2. Now we can continue on. For the total cost for 1, 2, 3, 4, and 5 hours, how much would cost for each part? Each time it's that flat fee plus how many hours times its cost, flat fee, how many hours times its cost. So there we go. We have that table fill up number 1, how much it would be. Number 2 here, explained how a customer could use this pattern. Hopefully we see a pattern happening here. Maybe you didn't need to do all these equations, but how they can use that pattern to determining how much it would have cost that 6th hour. Now, hopefully, as we were doing these, you saw every time we went down, what was that increase in value? Well, every time we went down, the problem, it went up by 2, went up by 2, went up by 2. Every time it went up by 2. So you could then correctly assume that if we went to that 6th hour would indeed cost $17. So explain how a customer could use a pattern. You could say pattern, it increases by 2. So the 6th hour would cost $17. And so that's a lot of what we're doing is, can we recognize this pattern that's happening? And if we can see a pattern, if we can recognize that pattern as being happening, then we can write an equation. And that's what we're going to be going to here very shortly. We want to write the pattern. But before we do that, we need to talk about something called the independent variable. X represents the independent variable. So maybe you've heard this in science classes before, but independent variable is the variable that you can control. So imagine you're going to the water park and you're going to rent this inner tube. What in this situation could you control? Could you control how many hours you rented for? Or could you control how much it's going to cost? Well, if you said you can control how many hours you rented for, you would be correct. You can control how long you have that tube, and depending on how long you keep that tube, that would end up determining the cost. So, in this problem, the independent variable is the number of hours. Number of hours, and we're going to let that be our X variable. So it's the number of hours you can control when you contribute. You control when you return. Control when to return. So whatever variable you can control, that is what is going to be referred to as the independent variable. On the flip side of that, the dependent variable, the y, is sort of the result, what ends up happening. And in this case, our y value is going to be cost. The cost depends on how long you keep the tube for. So this depends on the independent variable. And so that's sort of how you can tell the difference between independent and dependent. The dependent is calculated from that independent value. Again, you'll see these pop up in science, and you're going to see these pop up throughout the year as we go. So step 5 is asking us to write that equation to model this. So we're going to have an x and a y. We're going to have an x and a y. Again, x is the number of hours, and y is going to be the cost, how much this inner tube is going to end up costing us. So if we want to write the equation to model this, all right, we can say the cost is equal to something. Well, if we go up here, do we sort of see a pattern in these equations? Well, we kind of did, yeah. So it was that fixed rate plus how many hours we kept it for, and then the hourly cost. So we saw this pattern happening. We can generalize and write an equation by using our variable x. So we could say our equation is that fixed value, 5, plus the $2 per hour times how long you kept that inner tube. So this is that fixed fee. And that $2 is that cost per hour, And there we go. We have just written an equation in two variables. We have an x and a y, a dependent and an independent variable, to represent this situation. So step 6 here, how can you tell whether the equation we wrote, how can we tell if this is correct for our situation? One of the easiest ways is to plug it in, plug in a value. We know from up above, we already did that table of values, at 1 hour it should cost $7. So let's try putting that information in to see if we get it out, see if it actually works. So if I did 5 plus 2 times 1, if I solve this out, do I get that? Does it equal out to 7? Hey, it does equal out to 7. So that means our problem worked, our equation is correct. The equation we wrote in step 5 is actually this equation in two variables that represents the situation. So step 7 here, last problem, says explain how an employee could use his equation to determine how much to charge a customer. Well, now that we have this equation, we'll write it here again. 5 plus 2x. If you, as the employee, are trying to figure out how much to charge somebody, all you would need to know is how long that they kept that inner tube for, and you could figure out the cost. You would not have to go to that table and let's just say a customer kept the inner tube for 10 hours, 12 hours, 15 hours. You wouldn't have to make that table go down all the way to 15. We could now use this equation you've written, and we could plug in that number of hours, that time, in for x. So if they kept it for 15 hours, let's just say for 15 hours, it's a long time at a water park, but you could solve it. Y equals 5 plus 2 times 15. You could solve it for any amount of time. So this equation allows us, then we can throw some little notes here. The y is going to be the cost. Again, x is number of hours. But with this equation, we can now figure out the cost that an employee would charge a customer depending on the number of hours. Moving forward, we're going to eventually talk about graphing this and see what this looks like graphing. But for our purpose today, our goal, let's go back up, see if we met our goal today. Our goal was, could we create an equation in two variables to represent relationship between quantities? So our relationship was between the hours rented the tube and the cost. And between those, we followed through. Were we able to write that equation? We were indeed. Y equals 5 plus 2x would in fact be our equation. If you like to continue trying some of the problems, you may. But otherwise, I'll look forward to seeing you tomorrow. Take care, be well, and have a great day.